Welcome to Curie Electronics. This is the second part of SDSC 2022 Technician B Electronics question paper solution. So today we are going to solve the remaining 40 questions, that is from 41 to 80. The question number 40. This question, the last video I made a mistake while choosing the option. For this question, what is device shown below? The right answer is PMOS, because the arrow is going out, so it is PMOS. I'll write it here. Not able to tick. PMOS. So question number 41. Which splicing technique involves in the alignment and locking of broken fiber edges by means of positioning devices and optical cement? Positioning devices and optical cement. The method is the mechanical method. Question number 42. The logical equation of an XNOR gate. So XNOR gate, A and B are the inputs. What is the output? Y equal to AB or A bar B bar. So that is for the XNOR gate. So which is the right option? Option C is the right option. Which of the following is not a type of strain gauge? The answer is coil. Which of the following is not basic reason for modulation of signal? We will modulate the signal to reduce the size of the antenna, to increase the operating range, and it's for wireless communication, but not to encode an information. So option D is the right answer. A 5-volt DC source is connected to a series combination of 100 ohm resistor and 0.2 microfarad capacitor. What is connected? 5 volt DC. 5 volt DC. What is the current through the circuit under steady state? We know steady state means after 5 time period of the circuit. At steady state, the current flow is equal to 0. So option C is the right answer. Question number 46. Peak inverse voltage of a center tapped full wave rectifier. For center tap, only for the center tap rectifier, it is 2 Vm. Other rectifiers, it is Vm. Next, what is the input of the below given gate in the form of ABC? So here for A there is a bubble, B, C. So what is the input of the gate? After here the bubble means it's a NOT gate. The bubble means it's a NOT gate. So after the NOT gate, it is entering the gate. What is the question? What is the input of the below given gates in the form of ABC? So it is 0. It is going to be 0, 1, 1. 0, 1, 1 is the right option. Option C. Question number 48. The gain of an antenna is defined as the product of antenna efficiency and directivity of the antenna. Yeah, it is the directivity and the antenna efficiency. Option A is the right answer. In a CRO, what is the calibration signal generally available? it is the square wave. Square wave. I have not seen any CRO with a calibration signal sawtooth. And this is provided most of the old scope or new scopes. Most of the scopes are having square wave for the calibration, and it is given for the calibration of the probe actually. So I will go with the square wave only. Till I couldn't find anywhere it is mentioned as a sawtooth in any of the books. So please check it out. If you get any book where it says it's a sawtooth, please let me know. Question number 50. Which of the following method requires constant transmitter power for the signal transmission? The answer is pulse position modulation. Pulse position modulation requires a constant transmitter power for transmission. Okay. Next, question number 51. Maximum component density for a given PCB size can be obtained by. First of all, what? We have to use the SMD components. And the next what we need? We need a multi-layer PCB. So option A, that is a SMD components and multi-layer. Multi-layer means not 4-layer PCB, 8-layer PCB, 10-layer, 16-layer, like that. Question number 52. Which of the following oscillator cannot be used in low frequency applications? So it is going to be a LC oscillator. Here, which is the LC oscillator? It's a Colpitts oscillator is the LC oscillator. Question number 53. A 1000 joule work is done in 2 seconds. What is the power utilized? So what is work done? Rate of power is rate of doing work. P equal to W upon T. Power equal to rate of doing work. So what is the given? It is work is given as 1000 joules and in 2 seconds. So what is the power utilized? It is 500 watt. 500 watt is the, so question option D is the right answer. In the frequency response curve of an RC coupled amplifier, the frequency response curve of an RC coupled amplifier, a drop in the gain value at lower frequencies observed due to. It is output resistance of the input transistor, input resistance of the output transistor, reactance of the coupling capacitor, all the above. So the best option is all of the above. A 1 kHz square wave is applied to the circuit. The output waveform will look like. Output waveform will look like. So this is what, it's a low pass filter, or we can say it is a integrator circuit. Integrator. It's an integrator. So whether it acts as an integrator, to know that we can calculate the time period. We can calculate the time period. If you take for the given 5 kilo ohm, that is 5 multiplied by 10 to the power 3 multiplied by 0.1 microfarad. If we simplify, we will get the time period as 0.5 millisecond. And for a 2 kilohertz frequency, F equal to 2 kilohertz, what is the time period? T equal to 1 upon 2 kilohertz, 10 to the power 3. That means what? We can write it as 0.5 millisecond. So the circuit will act as a integrator. The circuit will act as an integrator. So the output is going to be triangular wave. Question number 56. What is the total impedance of RLC circuit with resistance 8 ohm, capacitive reactance 2 ohm and inductive reactance 8 ohm are connected in series across 230 volt 50 hertz? So we have to find the impedance. What is the impedance equation? Impedance equal to square root of R square plus XL minus XC all square. So what is R square? R square equal to 8 square plus 8 minus 2 whole square, which equals 64 plus 8 minus 2, 6 square equal to 36. So what do you get now? It is square root of 100. What is square root of 100? Equal to 10. So option D is the right answer, that is 10 ohm. Which of the following conditions are needed to properly bias NPN transistor amplifier? NPN transistor amplifier. What is the condition? Very simple. Forward bias the base emitter junction, reverse bias the base collector junction. So option A is the right answer. Forward bias. Which of the following conditions are needed to properly bias a NPN transistor? Forward bias the base emitter junction and reverse bias the base collector junction. After firing an SCR, the gate pulse is removed. Then the current in the SCR will be so gate, anode, cathode. To fire the SCR we can use the gate, but once it is powered and if the gate pulse is removed, then nothing is going to change. The current remains same. Remains the same. Question number 59. Pulsating DC applied to power amplifier. See, if you have an amplifier and if there is a pulsating DC, if you apply to that amplifier, we could hear hum from the speaker, hum sound. Question number 60. When we actuate a switch, an output lamp will be on, and when we deactivate the same switch, the output lamp will be still on. What kind of circuit is this? This circuit is a latching circuit. It's a latching circuit. Once the what we will do, once you push, it is a latching circuit. Once you just push the circuit and leave it, it will stay there itself, like a door latch. Once you latch it, unless we remove the latch, it stays latched. So it's a latching circuit. Question number 60. Question number 61. What is the logic level 0 and 1 respectively for RS-232 serial communication? So RS-232 is a serial communication protocol, and in that 0 is from 5 to plus 15 volt and 1 is from minus 5 to minus 15 volt. 0 is from plus 5 to 15 volt and 1 is from minus 5 to minus 15 volt. For a body moving with constant speed in horizontal circle which of the following remains constant? I did not go through it much, but the answer is kinetic energy. Which of transistor configuration has high voltage gain and high current gain? That is the common emitter. Two conducting wires, A resistance RA and B resistance RB, are made of same material and have same length. If the diameter of the wire B is twice that of wire, diameter of B is twice of A. The ratio of RA upon RB. So what we have RA equal to, we can simply write it as RL upon A, or the same thing we can write it as RA equal to rho L pi d square upon 4, which equal to 4 rho L, I'll write it here, which is equal to 4 rho L, 4 has gone up, upon pi d square, So this is our first equation, that is the resistance of RA. And now we want to relate it with RB. Now let me write RA upon RB. RA upon RB, which equals, what is RA here? RA is rho L upon pi d square. What about RB? So RB what happened? The diameter of wire B is twice that of wire A. Diameter we made doubled. So that means it is going to be rho L pi, instead of D we will get 2D square. Here 4 rho L is there, right? Here also 4 rho L is there. Now if we simplify, what happens? The rho L cancels. Here also rho L cancels. Pi cancels. Then what we have here, we have 4 upon d square upon 4 upon two d whole square is there. So it is 4 d square. So here 4 cancels, d square cancels. Then what is left? 4. So here option A is the right answer. The ratio of RA upon RB equal to 4. Which of the following is correct for a D flip-flop? Option A, the output toggles if one of the input is held 1. No, the D flip-flop just gives copy whatever is there in the input to output. That means the Q output is either set or reset as soon as the D flip-flop input goes 1 or 0. So option D is the right answer. Because for a D flip-flop, whatever is there in whatever is the input, it will just come out with a clock. So if it is 1, output is going to be 1. If it is 0, output is going to 0. Set means 1, reset means 0. Question number 66. In voltage regulation, Zener diode is used in, it is in reverse bias. Then all very simple question. A series resonant circuit has L equal to 1 millihenry, C equal to 10 farad. The required R for the bandwidth of 14 Hz. See, the bandwidth relation and the resistance is given by F2 minus F1 is the bandwidth, which is equal to R upon 2 pi L. Once you apply this equation, you will get the answer. So let's apply it. What is F2 minus F1 is telling? That is the bandwidth is 14 Hz equal to, what is R here? R we have to find R 2 pi. 2 pi. Pi is 3.14. What is the L here? 1 millihenry. 1 10 to the power minus 3. So now what we do? 14, let it be there. This 10 to the power minus 3 goes up. So it becomes 1000 R equals 2 pi. I'll write here, which is, so 14 equal to 1000 upon 2, 500 R equal to pi. Now R equal to what? R equal to 14 upon 500 multiplied by pi. If you simplify this, 14 multiplied by 3.142 divided by 500, you will get 0.0879 ohms, which is equal to, if you multiply by 1000, it becomes 87.9 milli ohms. So the answer is option A, 88 milli ohms. Question number 68. What is the current through the resistor in the circuit? The resistor is connected between Zener diode and 10 voltage Vin. So the Zener also we can replace with a voltage source. That is, this 290 ohm resistor is connected between two voltage sources. That is, one is 10 volt, another one is 7.1 volt. Right, we can replace a Zener diode. It's a Zener diode acts like a voltage source. So what is the current flowing through this? I equal to, if I is the current flowing through this, then V upon R. What is V here? 10 minus 7.1 upon R 290 ohms, which equals I equals 10 minus 7.1 equal to 2.9 upon 290. Now how do you simplify this? Let's multiply by 1000, numerator and denominator, 1000. No, 2 zeros only if you multiply by 1000. What about the denominator? 290 multiplied by 1000. So what happened? This 290, one will get this 0, 1 upon 100 we get, 1 upon 100. So what 1 upon 100 means what? 1 upon 100 means 0.01 amps. Okay, it is in amps. So when you multiply, if you want milliamps, multiply by 1000. If you multiply by 1000, it becomes, I'll write it here, 10 milliamps. It is 10 milliamps is the current flowing through this resistor. Question number 69. What is the functionality of the given circuit? It is the band pass filter. Option A is the right answer. Question number 70. What is the total capacitance of the given circuit? So when we connect two 4 microfarad capacitors, these 2 microfarad, when you connect, what you get equivalent for this? When you connect two pairs, this one, it's equal to C upon N. So two capacitors of same value are connected in series. That is 4 upon 2. We'll get 2 farad. Now 2 farad is connected in parallel with 4 farad. So what is the circuit we have left? We have a 2 farad, then 2 4 farads, 4, one more 4. Now we want the total between these two ends. Let it be A and B. So what is it? So you get, we have to just add it up, that's it. 4 plus 4, 10, no, 4 plus 4, 8 plus 2, 10. So it is 10 farad. So 10 farad is the right answer. Question number 71. What is DDR? DRAM. DRAM means dynamic RAM. So dynamic word is there in the second option, dynamic RAM. So it is option B is the right answer. Double data rate dynamic random access memory. The peak inverse voltage of each diode in a bridge rectifier circuit is that of the equivalent center tapped full wave rectifier. So center tap, it is how much? Let me write it here. For center tap, it is 2 times the VM. For a bridge it is VM. So what is the question? The peak inverse voltage of each diode in bridge rectifier circuit is that of, that of the equivalent center tapped rectifier. That is means it's half. VM is half of 2 VM. So option A is the right answer. The IP address size in IP version 6 is 128 bits. For IP version 4, it is 32 bits. For IP version 6, it is 128 bits. The difference between latch and a flip-flop is, latch is level triggered, flip-flop is edge triggered. So what is the option? Latch is latch is level triggered, flip-flop is edge triggered. So option B is the right answer. Question number 75. The sum of three numbers is 264. The first number is twice the second number. And third number is 1/3 of the first. So let me write it. It is, we'll take it as x plus y plus z equal to 264. Now he is giving the condition. First number is twice the second number. So instead of x, I can write 2y. Then y. Then what about z? Then y is telling the third number is 1/3 of first. 1/3 of first. That is, I'll take it as 2y equal to 0. Not equal to 0, equal to 264. Now how do you simplify? I will add these two y. So it is 3y plus 2/3y equal to 264. Now what could you do? We will just multiply by 3 the entire equation. Then it becomes 9y plus 2y equal to 264 multiplied by 4. What do you get? 792 will get. Now 11y equal to 792. What is y? Y equal to 792 upon 11. It comes to 72. The answer is 72. or let me tick the answer. It is 72. In an inverter, if the fundamental output frequency is 50 Hz, then the frequency of the lowest order harmonic will be the harmonic will be, fundamental frequency is 50 Hz, means next harmonic should be 2F, then 3F, 4F, like that. But here then it should be 100 Hz. After that 150 Hz. So the lowest if we go, it is going to be 150 Hz. The answer is going to be 150 Hz. But why they are not given the lowest? The lowest is 150 Hz. The answer is 150 Hz. Okay, let's go to the next question. If a transformer has turns ratio 1:2, the primary current is 20 amps, then what will be the secondary current? What he has given? Turns ratio. If the transformer has a turns ratio 1:2, so 1:2, so we'll write it as NP upon NS equal to, and the current we will write it as reverse, I secondary upon IP. Okay, now let me write it. What is NP? 1:2. So 1/2 equals, the primary current is 20 amps. What will be the secondary current? Secondary current you have to find. Then what is the secondary current? If we cross multiply this, what we'll get? IS equal to 20/2. You'll get 10 amps. So 10 amps is the right answer. Option C is the right answer. The maximum rate of change of output voltage caused by a step input voltage of an op amp is called. The rate of change of output voltage is known as the slew rate of the op amp. That is microvolt per second unit, the slew rate, or nanovolt per second. What is the output waveform of a comparator circuit if the input is sine wave? The comparator is a plus minus op amp. If you are giving here, there could be a reference voltage also. We can keep it 5 volt. Then we can apply the sine wave. If the input is less than 5 volt, we will get a high state. If it is greater than 5, input is greater than 5 volt, we will get a low. Like this it will be. So we will get a square wave or rectangular wave. Here rectangular wave option is there. So option A is the right answer. Question number 80. This is the last question. And if you like the video, please share with your friends. Also don't forget to hit the like button. If I have made any mistake, please point out. Also any clarification, and especially for that oscilloscope question, please let me know if anything if you have any material for it. Now what is the question? What is the period and frequency of the given waveform? So from here the period it is in seconds, because all answers are in seconds. So this is going to be from here to here. So how many divisions are there? If you see here, 0 to 7, a plus 1 is there, 1 division is there on the negative side. It is 8 divisions are there total. 1 2 3 4 5 6 7, 8 divisions are there. So for t equal to 8 seconds. Once you get the period, what is the frequency? F equal to 1/t. What is 1/t? 1/8. What do you get? You'll get 0.125 1 to 5 will get. F equal to 1 upon 5, 1 to 5 Hertz. So what is the right answer for this question? Option D is the right answer. That is 8 second and 0.125 Hertz. 0.125 Hertz. So we have completed all questions. So we have solved 41 to 80. So all questions got over. So thanks for watching.